Okay, we're going to look at unit conversions and different ways to convert units. Okay, so what's going to happen here? There are 3 ways to convert units that we're going to look at. Okay, you can either move a decimal place, you can use a ratio, or you can use what we call dimensional analysis. So I don't care which way you use or which one you use. All right, it doesn't make any difference. Some will be better than others for certain things. I would kind of pick with one way and kind of go with it, and then kind of ignore the rest of them. So the first we're going to look at here is just moving a decimal place. And this would have been the one you would have learned probably a few years ago or when you're younger. It goes with the KHDDCM. The King Henry died while drinking chocolate milk, usually is what you hear. Okay? So what happens with this one is you're usually just moving it to the right or moving it to the left. Well, if you're moving it to the right, you are technically multiplying because you're moving your decimal to be bigger. If you're moving it to the left, you are kind of dividing it or moving it to be smaller. So with the moving one, you can also just say whether you're going to multiply or divide by 1,000 or 100 or 10, and I will also take that way as well. It's a lot harder for larger units or really, really small units. So ones that are right around your base are the best for this way. If you have, nano or mega or giga or pico or something like that, those ones are not the greatest with this particular method. Okay, so let's look at an example. So if I want to say take 2,000 kilograms and convert that into grams, okay? So I'm going to have 2,000 kilograms and I want to know how many grams that is. Well, if we're using this particular method, I would say, okay, KHD blank DCM. Remember, the blank is whatever the base unit is. In this case, the base unit is grams, okay? And I'm starting out with kilograms and I want to go to the base unit. So I'm going to go 1, 2, 3. So I want to move my decimal place 3. So I take my 2,000 and go 3 more places to the right. 1, 2, 3. Basically, you are multiplying by 1,000. Okay? And so my answer is going to become 2 times 10 to the 6th grams. Remember, if you're moving to the right, you're kind of making it bigger. If you're moving to the left, you're making it smaller. Okay? And that's just the moving one. The next one we're going to look at is a ratio. Okay, now when you use a ratio, you have to use what's called a conversion factor. Okay, and a conversion factor is an equivalent value that's used to convert. Okay, they don't always have to be some number to 1, but it often is. And I'll give you an example for these conversion factors here, like the one over on the right. Okay, 1 meter is the exact same thing as 100 centimeters. So I have the smaller number 1 and the larger unit meters. I have then the larger number, 100, with the smaller unit. Okay, these two things are equal. 100 meters is the same thing as saying 100 centimeters. You could also say in 1 meter there are 1,000 millimeters. I have the big number with the smaller unit. I have the smaller number with the bigger unit. It doesn't have to be to 1 because 100 centimeters and 1,000 millimeters are the exact same thing. So I can also use these two as a conversion factor. I could say if I have 100 centimeters, well, that's the same thing as 1,000 millimeters. So we're going to look at a couple of examples using these conversion factors for ratios. If I have 3 meters and I want to know how many kilometers that is. So I would say, there's a couple ways you can do these. I can say I have 3 meters, okay, it's going to be what number of kilometers if, and here's my conversion factor, I have 1,000 meters in every 1 kilometer. Okay, this is a ratio. Ratio says these two, this thing here is equal. Okay, they're the same, and we're converting a unit. So if I had 3 meters, how many kilometers would that be? Notice there is an equal sign in between because they are equal. Okay, they're proportional. That's what a ratio does. You can also set up your ratio a little bit different. I could say, well, if I have 3 meters, how many kilometers is that? And I know that there are 1,000 meters in 1 kilometer. Same thing. Notice how I have either the same unit across from one another or I have the same unit on the same side. How you solve these then? Because there's an equal sign. We're going to cross multiply and divide. I would solve either one. Okay, we're going to say 3 times 1 is equal to 1,000 times x. So I have to divide by 1,000 to get x by itself. and take 3 divided by 1,000. You cross multiply and divide it. People normally do is this top one, okay? You would take 3 times 1 and divide by 1,000. Or just set it up and equal, right? Okay, multiply, equal, multiply. That's how cross multiply and divide works. I'll give you another example. Okay, we're going to do 2 of these ones. If I said 200 millimeters, and I wanted to know what number of centimeters that would be. Okay, I would say, okay, well, I've got 200 millimeters. What number of centimeters? Well, I know that 1,000 millimeters and 100 centimeters are the same thing. So I'm going to solve for this one. I'll take 1,000 times x equals 200 times 100. And I would just divide by 1,000. Okay, 200 millimeters is the same thing as 20 centimeters. Again, the other way to set this one up, goes in the other color, is to say that I have 200 millimeters. That's equal to what number of centimeters? There are 1,000 millimeters and 100 centimeters that are the same thing. So we're going to say that this is equal to what if these two are equal. Okay? You cannot, there's one way you cannot set these up. Okay? So you can't set these up where it would be 200 millimeters over 100 centimeters equals some number of centimeters per millimeter. You've got to have, they can't be across. The same units cannot be diagonal like that. Okay? They've either got to be on the same side or they've got to be across from one another. So this is a ratio. Remember, ratios again have the equal sign in the middle. So let's look at the next thing. What we call a factor label or dimensional analysis. Okay, these you set up with all multiplication and you try and cancel the units. So you start with the number you want to convert, then you put that unit on the bottom of the next thing. So when you multiply, the units cancel. It might sound confusing. It's actually very, very easy. So what I do is I want to say, okay, I want to convert 3,000 grams, and I want to know how many kilograms is that. I've got 3,000 grams. I'm going to multiply this time, not equal. I'm going to multiply, put my conversion factor, and say, okay, I want my units to cancel. So if grams are on top, grams have got to be on the bottom. And I want to go to kilograms, so that's what I'm going to use there. And I know that there are 1,000 grams in every 1 kilogram. So when I multiply across, this one here and that one there are going to cancel. And all you do then is say, okay, you multiply by what's across the top, you divide by what's on the bottom, because it's on the bottom of the number. So I would take 3,000 divided by 1,000, which is just the same thing as 3 kilograms. Okay? If I wanted to do the other example, I could say, okay, 200 centimeters is how many millimeters? I would start, say, all right, 200 centimeters, multiply, use my conversion factor, put centimeters on the bottom so it cancels, put millimeters on the top, 100 centimeters and 1,000 millimeters are the same thing. So we're just really going to cross those zeros out. 200 times a 10, which is 2,000 millimeters. Dimensional analysis, you have the big thing here. We have a multiplication sign. You're multiplying across the top, dividing by the bottom. But you're still using these same conversion factors. So the big difference between a ratio and dimensional analysis, let's put DA, you are multiplying and you're trying to cancel the units. If you are using a ratio, you have an equal sign, all right, and you're using a proportion. You're saying this is equal to that. They both use conversion factors because you have to convert it from one thing to another thing. You got to have the factor that has the conversion between the two of them. All right, so now let's convert derived units. Remember, derived units are multiple units. So we're going to convert 53 kilometers per hour, and we want to know how many meters per second that would be. Start off with our 53. Okay, I'm going to use a ratio. I say, all right, 53 kilometers. I want to get that into meters. So I treat each thing individually. So, okay, that's going to be equal to 1 kilometer is the same thing as 1,000 meters. So all you're doing is you're cross multiplying here. All right. 53 times 1,000 divided by 1, which is going to be 53,000 meters. Okay, it's per hour. So if I say it's per hour, that means I have 1 hour, and 1 hour is the same thing as 3,600 seconds. So what we're going to do is we're going to take these two numbers now. So I put them together. All we're going to do is divide 53,000 by 3,600, 14.7 meters per second. All right, which is pretty easy. If we go the other direction, though, it's not quite as easy, and I'll tell you what I mean by other direction. So ratios work well. They're not the greatest for a derived unit, I will tell you that much. They're a little bit more convoluted. You gotta know a little bit more about what's going on. So if I want to take 25 meters per second to kilometers per hour, I go back the other way. Again, the same thing, convert your meters to kilometers. We're going to get our answer for kilometers, 0.025 kilometers. I then want to convert my seconds. I have 1 second. Okay, if you don't know how to do that one, I would say 1 second is some number of hours. Well, there are 3,600 seconds in 1 hour, which means it's 1 divided by 3,600, which is 0.00028. And then you just divide the two numbers. I'll give you the answer of 90. So I'll go 90 meters an hour or 25 meters per second. Okay, we're going to try the dimensional analysis way. Like I said, I think this one's a little bit easier for derived units. Okay, if we would do a derived unit and do these same two examples, we'll do the same two colors then. Okay, I would take my 53 kilometers per hour. That's 1 hour. I'm going to multiply, convert my kilometers. So I put kilometers in the bottom. In 1 kilometer, there are 1,000 meters. That's converted, you multiply. Hours on the bottom, so I want hours on the top. Seconds in the bottom. And there are 1 hour, 3,600 seconds. You would just solve that. Take 53 times 1,000 divided by 3,600. You get the same number, 14.7. Okay, I would do the same thing for this red one over here. You would take 25 meters per 1 second times meters in the bottom, kilometers on the top, 1 kilometer, 1,000 meters times seconds on the top, hours in the bottom, 1 hour, 3,600 seconds. It's a little bit easier to do these because it's a little less thought. All you're doing is canceling all of the units. Whoops. You know, with kilometers per hour. You get the same number, 25 divided by 1,000 times 3,600. It's actually, I think, a little bit easier. Okay? Significant figures, last thing. Okay, if you're using a conversion factor, okay, what you are for all these, it's an exact number, so it doesn't go into the significant figures. So whatever your significant figures are, like to start with, is what you are when you end with. So technically, okay, if we see this one here, we started with 2 significant figures, 53. I really should round that to 15 meters per second. I am not that picky, all right, as long as you're within about 1. If you would have said 14.7778 or whatever that number is, I would have told you no, that's not right. But since I had 1 decimal, or just 1 place off, that's fine. Okay, the last page are just a bunch of examples. So you want to try and pause the video here in a second and try them and then check your answers. I will tell you that number 6 needs to be 56 kilometers per hour, not miles. Okay, we're going to stick with metric units. So number 6 should be 56 kilometers per hour. Okay, so go ahead, pause it, try some, check your answers. And with these, there are just 2 different ways to do the same thing. It does not matter which way you go. You'll do the same, come to the same conclusion or get the same answer.